Welcome back, ladies and gentlemen, to part 4. Let's get right into it. Examples. Write each degree measure in radians as a multiple of pi and each radian measure in degrees. So with number 1, we're given 140 degrees. We now want to convert this from its degree measure to its equivalent radian measure. So in order to convert from degrees to radians, we're going to use the ratio pi over 180. So when I multiply 140 degrees times pi over 180 degrees and simplify, this is the equivalent of 7 pi over 9 radians. So that's the measure of that angle in radians. Number 2, minus 30 degrees. Once again, we're going to take minus 30 degrees, multiply that times the ratio of pi divided by 180. After simplifying, we get the ratio negative pi over 6 radians. Here's number 3, 4 pi radians. Now we want to convert this angle from radians to degrees. So we take 4/5 pi, let me say that again, 4/5 pi times, now we use the ratio of 180 degrees over pi. After simplifying, we get 144 degrees. So 4 pi over 5 radians is equal to 144 degrees. Number 4, negative 7 pi over 4. So we want to convert this angle measure, which is now in radians, to its equivalent degree measure. So we take negative 7 pi over 4. We multiply that times the ratio of 180 degrees over pi. Then after simplifying, notice the pi's divide out. We end up with negative 315 degrees. So minus 7 pi over 4 is the equivalent of minus 315 degrees. Okay, ladies and gentlemen, we're moving into an introduction to what's known as coterminal angles. We'll be looking at both positive and negative coterminal angles. So in this case, looking at this rotated angle, looking at this black line here, and this little symbol here is known as alpha. Whenever we rotate an angle counterclockwise, as it was discussed earlier, this is a positive angle. So right here, let me label this. This is a positive angle. And now whenever we rotate anything clockwise from the x-axis, that's known as a negative angle. So let me label that right here. This little blue line, this is a negative angle because we rotated it in a clockwise direction. So now this angle is a negative angle. Let me highlight that a little better so it can be seen. So this here is a negative angle. So whenever we rotate a side from the x-axis and rotate it clockwise, that's a negative angle. But they all end up at the same value or the same location in this case. So we can either look at the positive measurement of that angle or its negative measurement, but in its standard position or its terminal side, these two rotations represent the same angle that this line makes with the x-axis. And let me show that to you. So in this case, the angle that this makes with the x-axis. So we're still talking about one and the same angle. So now we're looking at positive coterminal angles. Well, now in this case, as you see here, this letter alpha, the squiggly thing, we rotated that from the x-axis to its terminal position. So this is the terminal side, and this is a positive angle. And why is that a positive angle? What makes that a positive angle? Do you remember? Well, the reason why this is a positive angle because it was rotated counterclockwise from the x-axis. Now, a coterminal angle to this would be one in which we start here on the x-axis, we go 360 degrees around, we end up back at the x-axis, but now we do a partial rotation until we end up back at the same terminal side. And we're going to see what that means momentarily. So I have the original angle, and I have one of many coterminal angles. Well, ladies and gentlemen, let alpha equal the degree measure of an angle, and beta equal the radian measure of an angle. So these will be used in our next examples. So in our next examples, alpha will represent the degree measure of an angle, beta will represent the radian measure of an angle. So again, we're still looking at coterminal angles. We're given alpha is measured in degrees. So alpha plus 360 times n represents all angles that are coterminal with alpha. So let me do an example here. As you see from this drawing, we start here at the x-axis and we go one complete rotation around, then using a different color, and let's say that we have this line here drawn from the origin, so I draw this line. And now, in this case, if I wanted to show another coterminal angle, well, this would be 360 degrees. We now end up back here at the x-axis. And now to use a different color, so in this case, we have this line, which is the original angle. Let's say it's alpha again. But then we rotate it 360 degrees plus alpha. We still end up back at the same line. So that is what this expression says, that whatever you start out with in terms of your angle, and then from here we measure 360 degrees around, that's going to give us our coterminal angle. So to complete this, let me pick this color here. So we went 360 degrees plus the additional alpha degrees to keep that consistent. So starting from here, I went 360 degrees around, then we continued up alpha degrees. So this is another coterminal angle which includes alpha plus a rotation of 360 degrees. Well, in this case, n is an integer because we're looking at complete rotations. So this is the expression if alpha is measured in degrees. Now looking at radian measure. So now, as discussed before, we're going to let beta is measured in radians. So when we're looking at coterminal angles to that, we simply take beta and we do one complete rotation where 2n pi represents a number of rotations around the circle, because remember that 2 pi represents one complete rotation around the circle, because 2 pi radians is equal to 360 degrees. That is what we saw in a previous part of this video series. So to get angles that are coterminal to beta, we simply add 2n pi. That could be one rotation, two rotations, three, doesn't matter. Remember that n represents an integer, not decimals. So this would be the expression for all angles that are coterminal with beta. Ladies and gentlemen, that ends this particular part. Please have a great day. This is your teacher and instructor, Mr. Joshua Davis. This concludes part 4. Have a great day.